Hello everyone, hope everybody's having a nice day. You all know me, I'm Zach, and my project for this semester was the testing of medial heel wedges to correct for valgus and what our software could come up with. So, you'll also have to forgive me, I've transferred this from a Mac Keynote to PowerPoint, so some of the formatting is a little off, but I'll have correct files submitted when I submit the project. So let's get right to it. Knee osteoarthritis is a crippling diagnosis for anyone, often leading to reduced physical activity and the onset of disuse conditions, same as any other sedentary lifestyle. However, there is a direct correlation between medial or lateral osteoarthritis of the knee and a varus or valgus alignment. Now this was detailed in a study by Sharma et al., where 58.4% of subjects whose knee alignment was determined to be in varus had osteoarthritis, and 43.1% of subjects whose knee alignment was determined to be in valgus, they all had, those percentages had medial or lateral osteoarthritis. When the knee or any other joint is consistently out of correct mechanical alignment, osteoarthritis tends to affect all the structures within a joint through the loss of articular cartilage and the formation of bone spurs through incorrect bone remodeling. There may also be laxity in the ligamentous structure, which may allow for further malalignment to occur within the joint, which leads to an overall deterioration of the articulating surfaces. These conditions tend to lead to patellofemoral pain, or PFP, but according to a study by Felsen, this is often not caused by osteoarthritis during gait, as the patella does not articulate as much during walking as it does during climbing stairs or jumping. Now, while PFP is not the focus of this experiment, it is important to acknowledge the fact that knee alignment or knee malalignment tends to not only increase the likelihood of OA in the overall knee compartment, but that it is a contributing factor to the prevalence of patellofemoral osteoarthritis, which would further limit a person's ability to ambulate or to engage in beneficial and enjoyable physical activity. In a study by Werner, compressive forces on the knee after a total knee replacement were measured in 7 cadaver legs here. These are actually screenshots from the paper by Werner. And what they did was they either utilized a neutral, 3 or 5 degree varus or valgus angle. Whenever the knee was out of alignment, the difference in loading was quite dramatic. With the greatest distribution found, the knee was placed in 5 degree valgus alignment. In this alignment, the lateral compartment of the knee was found to be almost non-existent at 35 newtons, but the medial compartment showed 781.6. But when you looked at a normal loading, 323.5 newtons, 404.6, evenly distributed. So if we can correct the knee to natural alignment, correct mechanical alignment, we can alleviate some of these issues. While there are invasive procedures, such as the high tibial osteotomy, or even a total knee replacement, a simple and cost-effective method is the use of medial heel wedges, or lateral if you're dealing with somebody with varus, but instead of going through a surgery or using a knee brace, and according to one of the studies I read, the knee brace didn't actually help with the compressive forces, or the time-consuming and fairly expensive, in my opinion, modification of a shoe. They can actually we change the soles on them. You can add steel shanks into the sole. You can create a buttress on the outside of it that's really, really going to help. Now, of course, some people may have to go that route, But if we can correct it with something like that, that's pretty simple. I can glue one of those into a shoe in about, well, both shoes in about a minute. And that provides a very, very quick and effective fix. Now if I go back a little bit here, in a study by Fisher and all, shoe modification was performed in order to test for the correction of knee varus, and what they did was they modified the sole's rigidity. So they worked on the lateral side of the soles, and the biggest takeaway from that was that a 4-degree change, which would be somewhere around 1/8 of an inch, provided consistent results, but they weren't quite dramatic enough. But that an 8-degree shoe modification gave better results, but they weren't as consistent. I think that's fair. So knowing how we correct for these issues in mechanical alignment of the knee, it was my intent to actually do a measurement and see what happens at the knee before and after the installation of medial heel wedges into the shoes on a subject that suffers from knee valgus. Joint angles were calculated, as well as joint moments. And all of this was calculated using inverse dynamics, the Vertec force plates in our laboratory, and Cortex motion analysis software. So there was only one subject, sourced from our kinesiology and health promotion department. This subject had underwent ACL reconstruction surgery on their right knee, and suffered from chronic patellofemoral pain. So for the methods, subject arrived at the biodynamics laboratory, was outfitted with a Helen Hayes marker set on the following bony landmarks, of left and right when applicable. First and fifth metatarsal head, medial and lateral malleoli, tibial epicondyles, ASIS, PSIS, sacrum, and acromion processes. Subject was recorded in a static position and markers assigned in Cortex motion analysis software. Subject was then instructed to perform 5 separate walking tests at 90 beats per minute, where both feet made individual contact with at least one of the Vertec force plates. Once 5 trials had been completed, 1/4 inch medial heel wedges, which would be about 8 or 9, maybe 10 degrees, were inserted into the subject's personal shoes, and they were held in place by 3M double-sided hanging tape, as gluing them in just was not going to happen for a trial like this. A second static trial was collected to account for the shift in the lower limb markers, and then 5 more walking trials were completed the same way. So some preliminary results. Subject reported immediate relief of patellofemoral pain just from walking around the laboratory with these modified shoes. When analyzed in visual 3D, the knee valgus angle was reduced immediately once the medial heel wedges were added to the subject's shoes. And I have 4 figures. Well, here's the first one. So moment was calculated using visual 3D. And for these purposes, and based on the way that our laboratory is set up, the X direction is representative of sagittal plane movement, the Y representative of frontal plane, and then the Z of transverse. So starting here, the left knee moments, you can see primarily, but in every one of them, those moments were decreased. And this was just from adding the heel wedges. We see the same thing here in the right knee, but something that's kind of interesting to me is just how different those curves are after that ACL reconstruction. But same trend, similar curve between both trials, and a reduction from pre to post of the torques being applied at the knees. And here we have the angle, same thing. Same curves, similar curves, but all reduced on both left and right. But here, what's kind of nice is on the right knee, or on the left and right knee angles, they're a lot more similar than the torques that we calculated. So the overall conclusion, nice little formatting there. Both knee moment and angles were decreased with only the use of medial heel wedges modified into the subject's existing shoes. Also reported, to reiterate, reported the immediate relief of patellofemoral pain. And these wedges are cheap. We had piles of them in the O&P lab that I used to work in. It's fast. I mean, you know, if you had to, you could just tape them into somebody's shoes. If you wanted to do it right, you could glue them in. Granted, there are situations they're going to call for more than this, but this is a quick, simple, effective method for correcting knee valgus or varus if you switch the positions. One of the biggest limitations for this is there was only one subject, so there's not enough data to do statistical significance. So, you know, of course, with a lot more subjects, we get a lot more statistical power. As far as the future could go, a drop landing test would actually be a really interesting thought for me, to see how well that this could apply the forces in the correct direction in something so with a higher energy being applied. There are also some other ideas for that, but that's something to hold on to. Okay, here are the references. These are also included in my paper. Thank you for listening, and hope everybody has a great weekend. Great summer too. Take care.